So we have two squares, and the smaller square has sides 1 unit long. And we know that this angle is 60 degrees, which, because this is 90, means that this is 30 degrees. So we have a semi-regular triangle here. Find exact value of the length of each of the given line segment. AE. AE. Okay. So this is the craft and art of ignoring everything else. If you look at this right triangle, the shorter side is 1. In case of the semi-regular triangle, the shorter side is half of the hypotenuse. Why? Because it's half of the regular triangle. So without much work, I think we can declare AE to be 2. And then next one is BE. BE is that other side of this right triangle. So we already know two sides, 2 and 1. So 2 squared minus 1 squared under the square root is square root of 3. So BE is square root of 3. GH is this here. GH is in a new triangle, but this new triangle also have a side that's 1 unit long, but this time, if this angle is 60, this is 30, so 1 is now the longer side. In case of a 30, 60, 90 triangle, the shorter side is half of the hypotenuse, so we could call this x and 2x and run with the Pythagorean theorem that says 2x squared is x squared plus 1. So 4x squared is x squared plus 1. 3x squared is 1. X squared is 1 over 3. So x is 1 over square root of 3. Or square root of 3 over 3 if we insist to rationalize it. Now what's next? AG. AG is the hypotenuse in the same triangle, so that's 2x. So it's gonna be 2 over root 3, or if we want to rationalize it, 2 root 3 over 3. What's next? FG. FG is not in a triangle that has a side 1 unit long, but definitely similar, right? Well, actually, we don't know any side of this triangle yet. So similarity will not help us. However, we know that how long this is, and we know that the whole thing is 1. So this is just 1 minus x. And that's 1 minus 1 over square root of 3, or 1 minus square root of 3 over 3, if you want to rationalize it, or 3 minus root 3 over 3, if you want to rationalize it and bring it to the common denominator. I think these are equally acceptable final answers. Okay. Now, next up, we have to find EG, and we just found the shortest side in a semi-regular triangle. That's always half of the hypotenuse. So automatically, this is going to be twice the previous one. So we're going to multiply the previous one by 2. It's going to be 2 times 1 minus x. That's 2 minus 2 over root 3 if you double this form, or 2 minus 2 root 3 over 3 if you want to double that form, or 6 minus 2 root 3 over 3 if you want to double this last form. Either way. Okay, there's just one more left, EF. Let me just call this red line segment A just for a split second. And then this is 2A. And this is what we want to find. So by the Pythagorean theorem, that would be square root of 2A squared minus A squared. That's square root of 3A squared. That's square root of 3 times A. And A, something we just, A is 1 minus X, which is FG. So we're going to take, see, I like the first form now best. So we're going to take this 1 minus X, this itty bitty little line segment, and we're going to multiply it by square root of 3. And this is the form that will be best for that, because we're going to take square root of 3 times 1 minus 1 over square root of 3. And that's square root of 3 minus 1. You know, this result is telling me that we worked way too hard for this result, because if you remember, we found this to be square root of 3, and this is still 1. And so this is square root of 3 minus 1. This is not a bad thing. One thing that is useful is sometimes you look back, given your answer, you look back whether it's reasonable or it's obvious. And if it's obvious, you realize that was an easier way. And next time, maybe you're going to remember that. So you learn from looking back at your result that you may have not gotten in the most elegant way. Thank you for watching.